we have, we've got our M&M. We'll take the same one. So our M&M event that happens, and then we have our, let's just call it punctuality event. I like that word. Okay, so these are independent. So we could have the M&M happens 15% of the time, and it doesn't happen 85% of the time. Punctual 40% of the time, and doesn't happen 60% of the time. So these events, again, they're independent. So we put these on a Venn diagram here. They can either not happen at all, that's out here. Let's call this one the M and this one the P. They both happen in this area in the middle at, I'm going to get out my calculator just to go a little bit faster, just to cheat a little bit. So the middle section there is 15% times 40%. Okay, so this middle section here is going to be 6%. This is the probability that you pick an M&M and he's on time. That's when they both happen. Okay, now let's see the probability that neither of them happen. That's going to be this. So 0.85 times 0.6. That's the one that we just did, in fact, so I should have remembered that. That's 51. So that's the probability that neither of them happen. Now, what's the probability that you pick an M&M, but you don't, but brother's not on time? All right? So probability that you pick an M&M is 15%, and the probability that both happen is 6. So what's left over here is going to be 9. Yep. And then the probability that he's on time is 40%, and the probability that they both happen is 6. So what's left is 34. Is that right? Let me add up here. 9, 6. Yeah, okay, that adds up to 100. Good. So what I did is I just checked to make sure those 4 numbers added up to 100, because if they don't add up to 100, that's a mistake. Okay, so you can see here now that I just used a Venn diagram here to point out where all the probabilities lie within this different set of combinations. So we can see that this is the probability that they both happen at the same time. This is the probability that neither happens. Here we can see that this is still 15. This is still 40. Now, the thing I wanted to point out is you could say, what is the probability that one or the other happens? One or the other. Now, this might ring a bell that when you say one or the other, you have to subtract out these duplicates. Because if they both happen at the same time, well, you don't care. So I'm just going to throw this formula up on the screen for you and then let you mull it over, because this is a slightly more advanced, but it's pretty cool. So the probability that A or B happens, and I put it on the Venn diagram so you can visualize it, A or B. So that equals the probability of A plus the probability of B minus the probability that they both happen at the same time, because you don't want to double count that. So I'm going to say the probability of A and B. So the probability of A or B is the probability of A, so this circle on the left, plus the probability of B, this circle on the right, subtract the overlap, because you're just trying to get the or, one or the other. You don't want to add them twice. So 15 plus 40 minus 6. And